Well, welcome everybody. Thank you for joining us for our private investor meeting today featuring Saltenna. Saltenna is a wireless communications company enabling high bandwidth connectivity in oceans, ice, dense terrain, underground environments, and metal infrastructure, which are all areas where traditional RF systems fail. The company uses proprietary Surface Electromagnetic Wave technology, and Saltenna will transmit signals without line of sight, and it unlocks secure communications across 80% of the Earth, previously considered unreachable. The company has developed a patented wireless transmission platform designed for mission-critical environments across defense, subsea oil and gas, logistics, telecom, and smart infrastructure. Backed by strong government support and commercial engagement, the company is positioned as a first mover, reading access to the electromagnetic spectrum. We're going to have about a 20-minute presentation from CEO Dendy Young, followed by a Q&A. So if you have any questions, feel free to put them directly into the text chat, or you can private message Emily, Avery, or myself, and we'll be sure that your question gets asked. You can also raise your hand when Q&A starts, and we will call on you. Finally, we're going to be doing a confidential investor poll, so you can indicate your level of interest in investing in the company. So we have very interested, not interested, but you know an investor who might be interested, or the fourth category is not interested. And if we could have 100% participation, that would be awesome. So if you're not interested, no worries, just let us know, and we will keep all the results confidential except to the company. Finally, we have some differentiators. What differentiates Saltenna? They have a deep IP portfolio with 5 patents granted already and 42 pending. They have tremendous government validation, as you might imagine, over 10 million in recent non-dilutive funding from DTRA, USSOCOM, US Air Force, and US Navy, and commercial engagement as well through active programming with major oil and gas and maritime operators. Huge addressable markets, multi-trillion-dollar infrastructure sectors spanning defense, energy, logistics, telecom, and smart cities. This is a truly amazing and groundbreaking disruptive technology, and I'd like to turn things over now to the CEO and founder, Dendy Young. Dendy, thank you so much for sharing today.
Tim, thank you for inviting us. We're really honored to be here, and I really appreciate the work of your team, of Emily and Avery and so on, making all this happen. This is not a trivial activity. I'd like to introduce, to start, two individuals who are here on the call with me from Saltenna. One is Dr. Igor Smolyanov. Hello. And the second is Ashley Johnston. Hello. Igor is our chief scientist, and he's really the brains behind this. And then Ashley is our chief operating officer, and he just makes it happen. It's a remarkable talent of his. Anyway, the amazing thing about Saltenna to me is that I would never have imagined that there'd be a moment in time where we would have an opportunity to do something that nobody else had ever done before. I mean, think about that. And yet here we are as a company doing stuff with these plasmonic surface waves that nobody's ever done before. Why? Because nobody ever thought about them. And in fact, they date back to the early 1900s, when electromagnetism was hot, and it was the AI of its time. And so everybody was focused on AI and on electromagnetism. And what happened at that time was people explored every aspect of it, throughout the industry and the science. And because Maxwell came along and clearly defined electromagnetism, he somehow left out a piece which today we're using, called surface waves. Now, Nikola Tesla, who lived at the time and was one of the fathers of this process, he said, "I know there's something there, I just can't describe it," which was a very interesting perspective. And it's that which led me, in the form of conversations over time with many people, but most recently with Dr. Smolyanov. Igor, by the way, is Ukrainian-born, educated in physics in Russia, And that's the best education in physics that you could get anywhere in the world. And anyway, we're very privileged to have him as part of our team here. But Igor said to me when I was talking to him about it, he said, I might be able to help you make that work. And that's what he's done with Saltenna. So we've created Saltenna in effect to prove that that surface waves do exist and that you can use them in all kinds of ways that most people don't think about. Oops. So the problem we're solving, every company needs a problem to solve, and our problem is that there are places where normal electromagnetic waves don't work. One of those is, and the clearest one is underwater. You try and use your phone underwater, it won't work. But it also won't work if you put it inside a metal box, otherwise known as a Faraday cage, or if you have it inside a ship, or if you have it, there are lots of places down in the parking garage, the lower floors of the parking garage, it won't work there either. And the reason is it doesn't work where there's any kind of enclosure. The other place it doesn't work, by the way, is in deep sea infrastructure. And so, you have this crazy circumstance where a lot of our power and energy today is coming off the ocean floor, and we don't have an efficient way to get it out. Now, compared to $130 a share or whatever it is today, that's probably not a big deal. But it is a big deal because we could be getting it out very much less expensively than we do currently. And the other thing, of course, is underground. If you're in a tunnel, don't expect your phone to work because it won't. So the breakthrough here is that Igor figured out how we could use plasmonics, this concept of surface wave communications. And I must tell you, we're still early in that understanding in that process. We're far enough in that we can see specific capabilities and specific options for us, and we're now exploring those. One good example, for example, is we can go underwater now 5 kilometers. That's unheard of. If you talk to anybody in the Navy, as they've told me, that's not possible because they know you can't transmit electromagnetics more than about a foot underwater. But we're going 5 kilometers, and we stopped only because our customer at the time, who was trying to prove that we could go 500 meters, or wanted us to prove we could go 500 meters, said, "Stop! I want my boat back." And so we had to stop at 5 kilometers. We think that bandwidth is a critical factor. And although it's amazing what some of our competitors have done with acoustics, the problem with acoustics is it's just not a very high bandwidth, and it's not a very reliable medium anyway. But it's just, you can get maybe kilobits with, in fact, it's mostly hundreds of bits with acoustics, but bandwidth is not acoustics' friend. And then, of course, all of the places where you've got metal or some kind of, salt water or something like that, which conducts electricity, those with other forms of electromagnetics, they stop. Our electromagnetics, though, are surface waves. They travel along the surface, and it's a very different experience. So we started the company in 2017, and we've spent since then, which is now 8 years, basically trying to figure this stuff out. What is it? How do you use it? There's nothing out. There was nothing written. There were no guides for us to take. Well, you do this to start or that to start. No, we had to sort of start with a blank piece of paper, and it's taken us 8 years to get this far. I can tell you, it took me 5 years before I believed that what Igor was saying could be turned into a business. And credit to him and his persistence and determination, because we're here today because of that. And thank goodness we're here, because all of a sudden our customers now, which are primarily government customers, since they're willing to take the chance in us, our government customers are proving that what we have is of value, and they're funding us and have funded us this far to get this far. So all of a sudden, we're now moving into products. And so our first product is going to be something which we call diver to diver. That's probably not its final trade name, but it sort of describes what we're doing. And in fact, if you look at the fellow in the scuba diving outfit on the left here, he's actually using our diver-to-diver solution because it's pretty easy to use, and that almost all the stuff that you see is actually scuba gear, not electromagnetic transmission gear. We've also gone through boats. We had an opportunity up in Baltimore Harbor to demonstrate from the inside of the Torsk. The Torsk is an old World War II submarine. It's all metal. We were able to hide our transmitter in the far reaches of the Torsk, kind of on a tour there. And then we tried to see where else we could pick up the radiation. And it turned out that that whole ship acted like an extension of our antenna. And so we were able to pick it up throughout the ship, and also, by the way, outside the ship, because that's also an extension to our antenna. And if you want extensions to your antenna, have a look at the picture on the right, because that will stop any normal electromagnetic wave. But surface electromagnetic waves say, oh, this is great because there are lots of surfaces there that we can ride along. So who's the competition? You must have competition. We do have competition. It's called acoustics. And you can do amazing things with acoustics. I'm just blown away by the elegance of the sophistication of some of the acoustic solutions that are out there. But the problem is they're nothing compared to the things that we can do under the same circumstances. Turns out that with, oh, by the way, the acoustic solutions all bother the whales and porpoises. And of course, ours being electromagnetic waves, don't bother them at all, any more than your cell phone waves bother you or me. Optical is a very powerful technology, but the problem is underwater, it just doesn't go very far. It gets confused by murky water, it gets confused by distance, and it's very line of sight dependent, whereas our surface waves do not go point to point. They go around a surface until you get inside the into the destination. It's a very elegant. Optical's great if it's very short distances, but plasmonics, it basically is great wherever you are, and we haven't yet identified what those limits are. I can look you in the eye today and tell you that I do not know how far we can go underwater because we've never been able to try it. And we think we know we can go more than 5 kilometers, but is it 10 kilometers? Is it 100 kilometers? And to what extent? And that's with megabits in terms of bandwidth. We know that at 100 bits per second, you can actually go pretty far. In fact, that's how they communicate with submarines today. But we're talking about megabits and maybe multi-megabits. So it's not the same kind of thing at all. So we've got low latency metal, metal penetrating technology here, which makes a big difference. Our thought as we started building this company seriously was we had to protect our IP. And so we've done that. And we've got today 5 patents that have been awarded. It's a very expensive process. And one of the reasons, in fact, perhaps the most important reason that we're raising the money right now is, in fact, to protect and perpetuate these patents. We have 43 patents pending. And so that's a lot more discoveries that we made, since a year and a half ago that we really started filing patents. And now we're in a position where we've got these patents and they're all percolating through the Patent and Trademark Office. One of the important decisions we have right now is to what extent we file internationally. Should we file in Japan? Should we file in Europe? What's our best option here? And we're exploring those possibilities. Unfortunately, they all cost money, which is one of the reasons we really need your help. The most exciting thing about this page is that Patent Office feedback. In their conclusions on those 5 patents, they said there's, quote, no prior art. And what that means in legalese is they couldn't find any other technology that we're violating or which is in any which way competing with what we're doing. And it's an amazing position for us to be in. And we have a lot more patents that we'd like to file if we had the wherewithal to do so. So that's all great, guys. But what are you going to do about your markets? How do we turn this into real revenue so that people are actually paying? And we have several customer sets that we can go after now. One of the challenges we have is as we sit down and brainstorm this, we have so many verticals that we could go after that Lord knows it's sometimes hard to figure out what to do next. But we're not having any difficulty with that because we've chosen clearly that we want to have a really strong relationship with the US military. The US SOCOM in particular has been really good to us, and they really sort of captured the essence of what we're doing. They said, wow, if you can do that, imagine what we could do with swarming unmanned underwater vehicles, for example. And in fact, those swarms couldn't exist without Saltenna technology. We've got all kinds of wireless comms that we're working on. And so we've got a bunch of products. I've got D2D 1, 2, 3, 4, all in process right this moment. So we'll see some products there. We said we need something else. We've got to have something strongly commercial. And it turned out that we had one individual on our team, John Mulholland, who happens to be from the oil and gas industry. And he said, man, there's a huge opportunity here because it's very expensive to handle subsea drilling. And so he's helped us move into that direction. And then we've also got all kinds of things that we could be doing with ships and manufacturing and stuff like that. And so we want to keep it sort of fairly focused initially, but we know that the number of opportunities is much greater than we can identify. I'm not going to read through this for you, but it's just an idea of what what we've looked at and what we could be doing. The diver comms, the unmanned underwater vehicle networking, the submarine to surface, the ship compartment comms, all of those things are things that we can do very straightforwardly, and we're just moving into that stage right now of the company. And that's another reason we could really use some additional capital. We've been able to pull together a first-class team. I'm really proud and pleased with the team we have. We have obviously Igor and Ashley. We have Captain Brisley. We've got Sanji, and we've got John Mulholland. He's our oil and gas expert, and actually he lives in Norway. And so we're actually doing interesting things now with this team and beginning to build the engineering team under them. Our business model is pretty straightforward. We'd like to sell product. First of all, we've got to perform in our existing contracts, and we think that the government is going to continue to contract with us to solve their specific problems. We'd love to do that. We're going to build these commercial modules, and we're going to do licensing in those places where we don't have the volume or the manufacturing capability. Rather than build it, we will probably find partners with whom to license it and pick up the revenue from that. Let's see how that evolves in the next year. If you look at our financial situation, in 2024, we had about 800,000 in revenue. In 2025, we had $4.2 million in revenue. And this year, we're predicting those existing contracts will lead to another $4 million minimum. That we have a pipeline which could easily generate another $3 or $4 million. And then we have the beginnings of our commercial. And so we expect the company to double this year. And that's an exciting time in any company's life when you see the numbers doubling this fast. We're not aiming at huge bottom lines because we've got so much work we have to do just to reinvest in the technology that we're exploring. So we're asking for $3 million. It's actually part of a $5 million safe. We have $3 million essentially left on it. And we're going to use that $3 million, one, to build our first generation of products. And then secondly, to continue to build our IP moat. We think that's our long-term really defensible barrier to serious competitors. And then obviously we've got to continue to work on the sales and BD side, especially as we move into commercial. And then lastly, we do need accountants and lawyers and things like that. So there is a need for some working capital in the company also. This year, we'd like to complete this round no later than Q2. And then we've got a number of pilots that we're executing on. We've got real visibility on recurring revenue, especially from the licensing. And then I'm hopeful that by the end of this year, we will convert all of these safe notes into actual equity in the company, which gives us an opportunity to have a priced round with institutional investors. And so that's the plan we're on. And that's really the answer. That's what we're doing. So here we are. We've got an incredible breakthrough in science and technology. In science, this is nobody's ever done this before. We're using surface waves. We've defined surface waves. There's nobody else in the whole world that's ever done that. And we're so excited to have an opportunity to take that technology and run with it to the far ends of the earth here. It's a great opportunity. We've been validated and checked by the feds. They believe that to the tune of $10 million worth of non-dilutive funding. They believe that what we've got is real. They're seeing those real results. Revenues this year will double. We've got the patents in process, and we've got field demos which are exceeding the expectations of the people who are asking us for field demos. And so we just need more cash at this point in time, and it's a great time to join the forces with Saltenna and really take this company further. I've got lots of other slides I could show you. I think though that we'll stop on that one. And if you have any questions, Dr. Smolyanov is here on the technical side, and Ashley's here on the operational run the company side. And so, anybody have any reactions or any questions?
Yes, Dandy, we do have a bunch of questions, but first I'd like to put the investor poll up.
Okay.
And this is confidential. It's just for the investors in the room here. Would like to get maximum participation, guys. So the four choices are very interested. Let's set up a follow-up meeting. Interested, would like more information. Not interested, but you have some investors who might be interested, or the fourth option is not interested at all. So thank you guys so much for participating. And with that, we can kick off some questions. Again, if you guys have any questions, feel free to type them directly into the chat, or some people have been direct messaging me, and I'll put those in the main chat. I won't attribute it to anybody, but feel free to raise your hand also. But we do have quite a few questions. Joe has a question here. How can plasmonics travel underwater if they travel along the surface?
Igor, you have to answer that one.
Okay, so I probably need to clarify. So basically, we are traveling along the surface. So yes, again, these signals can travel underwater along the surface at some specific, kind of depth which depends on frequency. They can travel along the seafloor. They can travel along the infrastructure. And this is not only theory, we actually verified this. We did quite a few demonstrations to actually, if we actually did.
Yeah, but the electromagnetic waves have to travel from wherever the antenna is, which might be below the surface, for example, to the surface, and then travel along the surface before coming down to the receiver, which could also be below the surface. So instead of going point to point, it actually travels, from antenna to antenna, but it'll always pick the path along the surface to do that.
But it could also take the surface of the seabed.
That's true. We could also use it. Will those waves, and we've demonstrated this, will also use the bottom of the bottom surface of a body of water too. So the seabed or the bottom of a quarry, which is what we've tested in our case.
Fantastic. Another question for Igor. Can this be used to generate neural radiance fields?
Again, I'm not familiar with the definition, but if the general kind of gist of the question, like, can we use it in like bioimaging, then the answer would be yes, because like we are made of water. Okay, and basically we found
And we have lots of surfaces.
Yeah, and lots of surfaces, by the way, like the tissue boundary. So we found a new way to propagate RF signals through a human body, and we actually have several papers on this topic. Again, we are not actively doing it at the moment. We just did just a few laboratory kind of experiments, but it is potentially a very interesting application for our technology.
Mm-hmm. Thank you for the question. Hi, Tran has a question. Is your technology affected by high water pressure? Is the 5 kilometer deep underwater or closer to the water surface?
Okay, so this 5 kilometer number was actually like from like half a meter, like underwater from one point to another. But it's not affected by the water pressure. We can do communication underwater at 5 kilometer depth, if let's say like near the seafloor.
Great. Had a couple questions on licensing. Are you open to licensing tech? And also, can you elaborate on your licensing strategy, how you see value sharing with prime contractors and large industrial partners?
So yes, we are most certainly open to licensing the technology. We've already made a proposal to a mining company to license technology. We see this in various forms: direct licensing, access to our technology through license. We also are coining a strategy right now to license it through products. So companies who would like to use our antennas, we would license the technology specifically for the antenna. Also, we will be designing electronics to go with the antenna. This is another opportunity to license. But yes, also we are looking at licensing platforms. So essentially sub-communication platforms that could be used on, for instance, UUVs. We would give access to our APIs, give access to the interface to electronics, and this would all be licensing opportunity.
Got it. Thank you for that, Ashley. Darren Burrell, please break out the 2025 and 2026 revenue between R&D/prototype versus annual recurring revenue funding from the government.
Hold on a second, I'll pull that chart back up again. Yeah, I thought there was a chart here, which
somewhere there.
Yeah, there it is. So this chart shows 25 federal contracts, which was 4.2 million. And then it also shows projections for 2026. So we're expecting our existing contracts, existing agreements with the government to generate over $4 million in 2026. And actually that's could be revised up slightly because we've picked up another Cerberus since this was done. We have a pipeline of many opportunities, and so we're expecting in 26 to see another $3 million from that. I think that answers the question from the questioner.
Yeah, I think he wanted to have a split between what's the split between R&D prototype money versus annual recurring contracts, or do you have that handy? Or
yeah, annual recurring contracts are not really these are defined requirements. In other words, go execute on this vision For example, one of the requirements we're executing on right now is our ability to transmit underwater. And so they said, we want you to transmit 500 meters underwater. And so that was happened to be the one occasion. The customer gave us or lent us a boat or two boats. Ashley, you go ahead.
She's finished, and I'll take it up after that.
Okay. Gave us two boats, and we started going, 100 meters and then 300 meters and then 500 meters, and we met those requirements. And so then we went a kilometer and it was still working. We went another 2 kilometers and it was still working. We went 5 kilometers and it was still working. And the customer said, come back, we need our boat back.
So just to get back to the question of recurring revenue. So we're currently making proposals to customers on recurring revenue. We've made a proposal to a couple of defense contractors that are going to be annual recurring revenue. And this is what you're seeing here in 2027. I would say right now, probably 2/3 of that would be annual recurring revenue. So that's the start of our annual recurring revenue. On the federal pipeline, you're probably looking at about half of that would be in 27, what you could term as annual recurring revenue.
Thank you. John had a question about the safe. Is there a cap on the safe?
Yes, there is a cap. It's a $50 million cap. And we believe that the valuation on this next priced round will be higher than that.
Thank you. Sulaiman, I think your question was answered on government. If not, you can type in follow-up question there. Joe had a question. How far can they travel underwater? Is it hard to understand a scientist? Oh, okay. I guess they're having trouble hearing you because of the echo, Igor. But how far can it travel underwater?
Well, the farthest we demonstrated the travel was about 5 kilometers at like half a meter depth, roughly speaking.
So the issue here is you've got to recognize, number one, those waves are traveling along the surface. They're surface waves, and they do extend down into the depths of the water, and they also extend, by the way, above the surface of the water, or above the surface of the bottom of the ocean. So, but that's their primary traveling distance, that primarily traveling environment, and the extent to which they go above or below is really, something we have to use in order to be able to access these surface waves.
So the maximum depth at which we actually tried it underwater was roughly like 50 feet, I would say. Basically, at the bottom of the quarry, which we used to do like demonstration and experiments.
So just to round off an answer to that question, so 5 kilometers we've done, and we could have gone further, but we had limited access to equipment in order to complete that. But these are right now, these tests are done with unoptimized systems. So the better we get at this, the more we understand this plasmonic modeling, we are going to get much better at this. We're going to go deeper. We're going to go further. We've already got ideas about how to make our antennas better. We've got ideas about how to make the electronics better that drive the antennas. So what you're hearing here for data is first instance.
That's right. This is the first demo.
Yes, we believe we can do a lot more. And these products that we're looking right now at licensing are first generation products. So we have a roadmap. The roadmap stretches out some years, and we believe that even our first instance in product is it's people are very interested in it.
It's a dramatic impact on any number of different vertical areas already.
Thank you. Another question, how do you prioritize among underwater, underground, and through metal use cases in your near-term go-to-market roadmap?
It's not a question of the roadmap. It's a question of what our customers are asking for. And if our customers ask for it, for example, we have a proposal in right now to a mining company, because a mining company discovered that we could do this, and they said, "Can you transmit through a mine, through a mine tunnel?" And we said, "Well, we believe so." And they said, "Well, how much money would it take for us to to prove that?" And so we submitted a proposal, and we may hear by the end of this month what the decision is by that mining company as to what we can do for them. And so we have a proposal into them to literally go through their mines, through their mine tunnels, and demonstrate our ability to communicate without using any other infrastructure.
Wow. Carl asks, is there a video you can share to show from the demonstration? And can this be dual use? Well, for sure it can be. But what about the video? Do you have a video?
I don't have it easily at hand.
Yeah, I believe I have either, but we can certainly, after this, we can send a link to a video.
Yeah,
I can try.
Yeah,
but I mean, there's like YouTube link.
Yes,
We can send to
yeah,
everyone.
we can send a YouTube link to everybody. Yes.
Oh, great. That would be awesome. And then we have another question. Your website indicated your technology can be applied to airport runways, et cetera. Can you please elaborate?
Well, it dates back to a request by the U.S. Air Force to come demonstrate this alleged technology. This is the Air Force just sort of reaching out and saying, "Hey guys, if this is really true, come show us." And so we went out to the Air Force Base in Hawaii, and we sat Igor in the belly of a C-17, which, as you may recall, is a very large aircraft, but it's basically a big metal tube. And he sat in the middle of that aircraft and was able to transmit to the outside, and not only to the outside, but also through two other airplanes, which happened to be on the fairly close by. And we then went as far down that runway as we could before we hit the outer boundary and couldn't go any further. And so once again, we're able to demonstrate that adjacency to a surface, and that runway is a beautiful surface, and we're able to use that to, in effect, do this. Now, one subtle, new and interesting point here is that most electromagnetic waves expand from the primary antenna in a 3D basis. And so the actual power that you get at any point in that part of the spectrum is actually declines based on the distance by 1/r². Hate to use these technical terms here, but it declines very quickly. If you're on a surface, however, it declines at the rate of 1/r, and that means that an existing amount of power allows these surface waves to go much further from the origin than they could otherwise do. So, I mean, it's really exciting stuff that we're dealing with here.
Question on SBIR. Are you planning to pursue SBIR? What percent of your non-dilutive money is SBIR grants?
I'd say it's running about half. The other half is an OTA. And so we're also pursuing OTAs. We're also pursuing, at this point in time, we have proposals in for 2 programs of record, which will be decided, presumably in the October timeframe. So we're playing all of the options and opportunities in the federal space.
Mm-hmm. Next question is more of a broad question here. What are the main technical or regulatory risks you still need to mitigate before large-scale deployment across your priority markets?
Well, the one challenge we have right now with our diver-to-diver comms solution is the FCC, because the FCC needs to regulate any transmitted information, right? Makes sense. The problem is how they're going to test it underwater. And so we haven't been able to figure that one out yet, but we're about to present that challenge to the FCC, and we'll let you know at the next meeting how it works out.
Okay, that sounds interesting. So they don't have a way to test it?
Well, they do, but
Yeah.
you know, they don't test electromagnetic waves underwater because everybody knows that electromagnetic waves don't transmit underwater,
Right.
right?
Oh, that's
Except
interesting. Okay, another question. How are you thinking about export controls, ITAR, EAR considerations, and international markets for dual-use plasmonic communications? ITAR is the International Traffic and Arms Regulations, and EAR is the Export Administration Regulations.
right? We're very familiar with those, and we have. You want to deal with that, Ashley?
Yes, we actually one of our senior staff, Captain Grizzly, retired. She has a lot of knowledge in this area, so we are working with those agencies. We've already we've got quite far with them in that they have given the okay for much of our technology. We are still working with them. ITAR, we're quite far. EAR, we're still working on. But again, we're trying to reduce the use cases to be very specific when we get in front of these agencies. And I guess what we can say is so far so good. We will be doing some work in Norway. They've approved that. So yes, we are addressing that head on, yes.
Got it. Thank you for that. Are there any other questions? People can either type it into the group chat or raise your hand and ask. Is there any connection to the Center for Metamaterials and Plasmonics?
Okay, I know the center. I'm familiar with the Duke University group, and well, I have actually I mean, reasonably good friends there. And again, I was there at the beginning of plasmonic field myself. I'm doing it for close to 40 years, I would say. So yes, I know pretty much everybody in the field.
Great. Any other questions? Do you know David Smith at Duke University?
Yes, I interacted with him, yes. And by the way, he referenced my papers. I cite his papers.
Great. Darren has a question. How much of the raise is going to patents versus production?
Probably, let's see what. Probably about 25% of the raise will go to patents. We're using an IP lawyer who is also spearheading the use of AI in submitting these patent applications. And so we're trying desperately to reduce our costs. And we think that even though it's in early stages for his technology, that we're probably reducing our costs by about a third compared to what they would be if we were just using normal patent lawyers.
Thank you. Great. We have some time for another question or two if anyone has anything. Otherwise, I'd like to thank you guys for joining us today. We will follow up. Dendy will follow up with each of you. We have this meeting recorded, so we'll have a recording available. And yeah, I really appreciate you guys joining us. Dendy, team, any final thoughts or comments here?
Well, my final thought and comment is this is the most exciting thing I've ever done in my life. If you think about the prospect of being on the forefront of a brand new technology, which could explode into so many aspects of our lives and basically take electromagnetic coverage to everywhere that today you can't take it. I think that's a very exciting opportunity. I'll leave you with that thought from me. Igor, you have any thoughts? Ashley?
Well, it's absolutely extremely interesting field, and like the number of applications or potential applications is huge, and again, I'm constantly amazed doing it.
If he's amazed, then I'm really amazed.
Being in the telecom business for a large part of your career, and you come up against an opportunity like this, you just can't say no. This is a paradigm shift in communications. This is going to change things dramatically. It is sort of a third rail, you could say, in communications and telecom. So not to be part of this is just to miss, is to stick your head in the sand. I could not refuse when Genji offered me, yes.
Yeah, agreed, 100%. And John, maybe, yeah, you can set up another meeting with Igor and team if you want to learn more about his Eureka moment. But with that, we'll go ahead and adjourn.